And we're back. Okay, let's talk to it. We are doing number 15. Isn't that right? Yeah, 15. Okay, let's start with number 15. Sorry. So, degree of the polynomial. Remember, the degree of our polynomial is our highest exponent. All right, it's a variable with the highest exponent. All right, it's the sum. Okay, so I have x to the fourth. That's my highest exponent, so my degree is 4. Okay, the leading coefficient is the constant attached to our highest degree term. Our highest degree term is x to the fourth. It's negative, so it's negative 1. Remember that our possible number of terms, okay, possible number of terms is this minus 1. It's our degree minus 1. Okay. Our possible real zeros and our degree are going to be equal. 4. Should be the same. Okay. So remember our chart. We had a little chart when we made this, and I'm going to do my best to make it as legible as possible. All right. With this little mouse, it's going to be kind of tough, but I'm going to do my best. So we have two options. All right. Our function can either be even, our degree, or our degree can be odd. All right. Even degree or odd degree. My leading coefficient. So this is degree even, degree odd. My leading coefficient can either be positive or negative. Okay? So if my leading coefficient is even and positive, my end behavior will look like this. As x goes to negative infinity, y will go to positive infinity. As x goes to positive infinity, y will go to positive infinity as well. If it's a even negative leading coefficient, they will go down, down. If it's odd, remember odd alternates. So it's down, up, and up, down like that. Okay? That's our chart. Alright, so here I have a even degree negative leading coefficient. So I know that my function, no matter what, should finish down, down. I should have arrows pointing down. Okay, that means my function should open down. Alright. To show my work, I'm going to show my work over here, so I want to set my function equal to 0 and solve. First thing you should ask yourself, is there a greatest common factor? There is. Now I can take out a positive x squared or a negative x squared. I'm going to take out a negative x squared because I want my first term to be positive and my second term to be negative. When this happens, it'll be easier to solve. Okay, now if this was negative, alright, I could have just added that. I could have added that to the other side. Although I like my x squareds when solving to be positive. Oh my goodness. Can that be a squared? Holy buckets. Wow. Pause. Sorry. So I got it to be squared. So then I get to take a square root of both sides, and I get x to be plus or minus 3. Now I also have this negative x squared equals 0. So I'm going to have x equals 0 because I'm going to divide by negative 1, and the square root of 0 is just 0. However, this root, alright, this root is going to have a multiplicity of 2. A multiplicity of 2. Because of this, because it's x squared equal to 0. So you can think about it like this. This is x, or negative x, times x equals 0, right? I could set each of those pieces, so the negative x and the positive x, I could set them both equal to 0, which would give me 2 zeros. Now it's tough to understand, like the zeros have multiplicity to do some. it's tough to understand when 0 has a multiplicity of 2 sometimes. However, I like to think of it like this because I'm writing it twice. Okay, x has, or 0 has a multiplicity of 2. So if I write, okay, 0 comma 0, that's a 0. Okay, I'm going to write multiplicity of 2, and then 3 comma 0 and negative 3 comma 0, and these both have a multiplicity of 1. Then I realized I didn't write them up here. I'll write them up here as well. 0, 0, 3, 0, negative 3, 0. Okay, so I'm going to go to my graph and plot my roots, my x-intercepts. All right, so how far up and down your turns are doesn't really matter, as long as your end behavior looks like this. As long as you start from down here, and since there's a multiplicity of 2, I bounce. Now I'm doing my best, that's a bounce, and come back down. As long as you start up in the bottom and end in the bottom. Okay, that's supposed to be a bounce. It was tough. This is lagging a lot. That bounces off 0. All right. So as long I could have, remember, I can have something that looks like this too, and it would be totally fine. I could have that as well. All right. How far up and down you go does not matter, as long as you're hitting your 3 critical points and your end behavior is true. So my end behavior here should be negative infinity and negative. Sorry, I forgot to fill this out. Sorry, I forgot to fill this out before. I actually have negative infinity and negative infinity because they're going down, down. All right. 16. 16. Okay, solve the equation using U substitution. Okay, so I want to figure out what is causing the problem here. Okay, what's the problem? The problem are these fractional exponents. Okay, the problem I'm having is with these fractional exponents. Okay, so I want to think about, all right, what could U equal? What could I let U equal? Well, I can let U equal, if I let U equal x to the 2/3, all right, and I were to square that, I would have x, remember, because if I raise a power to a power, I multiply, I would have x to the 4/3. Well, that's not what I want. Okay, this is my process of checking that I use the correct value for U. So I don't want 2/3, I want to let U equal x to the 1/3. Because if I square 1/3, 2 over 1, oh, that would give me x to the 2/3. Okay. Sometimes people are going to say, oh, well, can I just, pick this right here? Yeah, that's true. Most of the time that's going to work, but there may be a case where that doesn't work. All right, can't you just pick your middle term? Yeah, most of the time that will work. But sometimes, and what if it doesn't? And then you're going to be mad at me when I say, well, you said always, and I don't like saying always, so I didn't say always. So I'm not saying always. So U squared plus 11U minus 3. Now that's something I can factor pretty easily. All right, this is a number greater than 1, so I'm going to use split the middle term. So I want to figure out what multiplies a negative 12 and adds to 11. All right, negative 12 and adds to 11. That's got to be 12 and 1. So plus 12U minus 1U. Do you need to write the 1? No, you don't do that. Equals 0. 4 terms factored by grouping. Find the GCF here. 4U. U plus 3 minus 1. U plus 3 equals 0. these are the same, so I win. Alright, so I want to rewrite my factor. Rewrite this as a product of our factors. There we go. For u minus 1 times, holy buckets, I'm going to freak out. Holy cow. Okay, got to pause it. Okay, had a little malfunction there. Alright, so now I want to solve each factor so each factor equal to 0. So 4u minus 1 equals 0. So u equals 1/4. And this will give me u equals -3. Alright. Now, our original problem had x, so I need to solve for these. I need to substitute my x back in. So it's x to the 1/3 equals 1/4. And x to the 1/3 equals -3. There's two ways to think about this x to the 1/3. I'm going to show both using each side. Alright, so I can think of this as the cube root of x equals 1/4 if I want. Okay, and cube both sides. Get x equals 1 cubed is 1, 4 cubed is 64. So that'll give you, that's one way to do it. Or, this is a fractional exponent, I can raise it, which is what we're used to. I just wanted to show you both. I can raise it to its reciprocal of 3/1. And that's the third power too. Okay, so x also equals -27. Wow. That's a 27. Thank you. Thank you, technology. Here we go. Holy buckets. Okay.